Are we live? Yes, we are. Okay. Very quick introduction to what we're doing today. So basically, solve this challenge that is from Curtis Holt, if I'm not pronouncing his name incorrectly. And those are the requirements. I like our challenges. It's technically a Blender challenge, but he allows more than just Blender. So now we're gonna just do Rust graphics. I do more graphics than audio, so now maybe the streams will be nicer. I don't know. So what we have here is basically these are the requirements. 30 frames per second with this aspect ratio, and then this is the team, right? So laying the groundwork today, I want to implement this, which is Game of Life, using glium. See, I've made preparations for this stream, which is glium. So this is just like a safe wrapper for OpenGL. For those who don't know what OpenGL is, it's what basically enables you to use your GPU. So we can just copy this, and this will like build out the window. But for those who have developed something with OpenGL, they know how painful it is to actually start writing. So I'm not gonna bore the stream audience with writing all of it. I've prepared something that if I run, it generates this. Basically, it draws a quad on the screen. I'm gonna try and change these for illustration purposes. So yeah, okay. What we're gonna do is basically change this. Oh my god, that's not a valid syntax. Okay, the stream is already failing, guys. Okay, so let's do this, right? These are basically the vertex positions as rows, but if we run it again, we'll see that now the quad is like, this is two triangles, this one and this one, right? And then that's the background of the OpenGL. And we have a shader context right here, so we can like actually do some shaders. Okay, and we're gonna implement Game of Life on the GPU today, hopefully, maybe even. Those are the shaders. I'll probably like try and get them out of here and maybe place them in some files, maybe a YAML config down the line, but for now, I think that's fine. So let me go fast through the code so everybody's on the same page, everybody understands what is going on. Sip of the tea. Okay, so this is a lot of kind of not that good. I mean, this is like a copy template that then I altered it so it like fits better my purposes. But yeah, this basically enables shaders, and then I'm doing this where I'm passing the resolution and then also the time, and I'm naming them to suit GLSL viewer. For those of you who don't know what that is, this is a very nice project that basically like visualizes your code or like your shaders. It's a shader utility, and it like skips over some of the pains of OpenGL. But I wanted to practice Rust, so we're doing it in Rust now. Get used to it. So what are we gonna do then? We need to okay, so first let's actually generate a bunch of cells, right? Let's generate a bunch of cells, and they can be on or off. That's the first thing that we want to do. So here, the vertex shader that basically like gets the positions and draws them in the same place. I think what we're gonna do is let's return this to its original thing. Can you please do your thing? Cool. Yeah, okay. So let's see. Let's see. First goal for this stream, make like a grid that we can like put on or off on the cell. That's fine. So we can just use pixels, but then that will be like too small, right? Or like not too small, but it will be just like way too hard to see, and probably there will be compression issues. Maybe, I don't know. But yeah, we'll implement the rules of game of life and stuff like that. But first, quality changes, which means I'll have to Google it again. We want to break out these files, or actually, I think only the fragment shader is fine. But what I want to do is basically, when we reload this file, or this file is changed on the disk, then it will be recompiled and changed in the GL context. The thing is, like, this happens once, right? So that is interesting. Yeah, okay, let's do this. So first, let's make the thing fragment under GLSL, or we can even call it like shader.frag. Why not? We want this. Shader.frag, and we copy this in. I think, yeah, this automatically recognizes this GLSL, and maybe it will like spit out some errors. We'll see. We will see. So we return back to here. We want to basically get this from a file. So let's read a file in Rust. I'm gonna be Googling documentation because I don't want to seem like I have no idea what I'm doing. So it's better to just Google stuff. Okay. We don't really want to do this. Yeah, I think this is fine. We probably want to do it through like the file interface, right? Yeah. Ah. Of course it's Python. Ah, look at that. We have like a whole masterclass for reading a file. But yeah, we can just read it to a string and if it fails, we can just panic and leave a message. Yeah, why not? Is this a nice main function? Let's actually make this a result, and then box dynamic error. Oh my god, so cool. Yeah, so what this does is basically like it allows me to use a question mark instead of unwrapping stuff, which saves almost no time, but it's nice. And this will actually show me what the error is. I think I'm now gonna hard code the shader, and then maybe we can use clap to do something interesting. Okay, for now I'm gonna hard code it, and this will be, what do we call it? Shader.frag. Frag. Alright, we probably need to import this. Damn, is it std.fs? Yeah, okay. So this is actually a result of a string, and then we just want to unwrap it by using this little question mark thing. can we actually do as str? Or will this drop... This actually will not drop the memory. Interesting. Interesting to know. So, basically, now we should have the shader code. Let's try and run. See what happens. Okay. Let's see. So this is actually the trait error. Can you import it? Hell yeah. Let's see. Yeah, okay. That actually, I expected that to happen. So this is basically like something that owns the string, and then we're trying to pass it as a reference, correct? Or like, we basically have something that owns the memory, and then we say, okay, I don't want to keep that handle, and then the way Rust works is I think it drops the memory, and we can basically not have that handle, because now this is a reference to that memory, but this memory only exists with this handle, if that makes sense. Yeah, it is Rust, ladies and gentlemen. Let's just make the ugly solution. It should look like this. Yeah, I'll probably like there's some lifetime problem. Oh yeah. This is actually the string. And that should be fine. There's a warning. And there it is. So now if we change something in our... Where's that all highlighted? What's Rust Analyzer having a stroke? What is this? Hello? It's interesting, eh? Yeah, my roommates are being loud. It's fine. Yeah, so let's say we want to actually change something. Now if we change the shader, this should... What? How's this unreachable? What did I do? I just compiled, no? Did I do something stupid? So this will be this will be the fragment owned. This will be this. Yo. What? How is this unreachable? What happened? Okay, I think I made something that was not completely correct. So this thing, I'll just do that. Okay, hopefully this runs, even though... Okay, now if we change the shader, everything should be fine. I really want to do the thing where like it updates automatically. Like if we run it and then it updates, or like the code in the thing changes, we can like catch that and update the shader. But I don't necessarily know how to do that. Yeah, let's try it. Okay, now this shader, this file controls like actually how it looks. Cool, cool. Okay. So we probably need to like define a GL texture that will like house all the game of life values. So let's first see any code following this expression is unreachable. Why? That is not true. Probably want to do this, right? Yeah. It's a complete. That is interesting. Event loop run. Okay, how about we scrub this, make this return null, and then stick to the template I have. Here, let's just unwrap this. It will give us some error. I can do expect. Yeah, because the compilation there will fail anyways. So let's just say something like file doesn't exist. Let's just unwrap whatever. It's probably not the only fail that can happen, like something with flock or whatever can happen as well. Okay, that was a bit too much in terms of stuff. Let's create a description for this. Yep, okay. So now we've created a description. And let's do Pomodoro, right? We're gonna set up 25 minutes from now, and then have a little break, maybe chat with the chat, stuff like that. This has been good. All right, we'll see how it is. Okay, we're going back to this. Life is a game. What a creative title, right? Incredible. Okay. So we want to first thing, let's try and make the grid of cells, right? And we're going to define a buffer based on that grid of cells. So that is interesting, eh? Yeah, let's see. We have a vertex buffer. Can we have like an image buffer? Can I even write this? Let's see. Yeah, we need to just house the last frame, I think. Oh, we can actually... Interesting. The draw frame buffer is used as destination for rendering, clearing, and other writing operations. The read frame buffer is used to. That's interesting. So we can definitely try and do that with glium, like just generate some frame buffer and read in GLSL maybe even. I wonder if I can do that through a uniform, or I need to switch them. I don't know. Frame buffer, multi-output frame buffer. Output 1, output 2. That gives us these. Interesting, eh? Yeah, I mean, we can pass stuff through 2 channels. So we can, like, make a colored game of life or something like that. Or, like, if we want to stylize. Can I use this frame buffer anywhere else? Let's see. Yeah, we can do that. Because, if you recall previously, we actually can create a texture here. Interesting. Are we creating a texture? Let's see. So, damn. Frame buffers allow you to customize color depth stencil buffers. Fine, but let's see. What's that made? We compile the program. Damn, that is interesting. So this will draw over this texture. Can we bind this buffer? Can we bind it to the context? All textures do not have internal front end. Okay. But what? Okay, we probably need to actually see how this is done, right? Because this vertex buffer is, yeah, we pass the vertex buffer, we pass that, and then what do we do? Yeah, this is closed. And then we're creating the uniforms. Display the draw. So yeah, this actually gives us the background here. I'll prefer that to be 0. Even though, like, I don't know, kind of want to make it magenta so it is very distinguishable. If you're not really sure what I did here, is if you remember to the beginning where I showed this, now the code will be inset into the thing. Yeah. Oh. What? Doesn't blue and green make magenta? Yo. It is blue and red. I'm so bad at this. I forgot. Okay, now it's magenta. Fun fact about this, by the way, it was used during printing because magenta is obviously not that well used color, so it still holds pretty nice for the thing. Yeah, this is nice in terms of, yeah, this is actually just 2 positions, right? And then if you see here the vertex buffer, oh, that's so cool. That is so cool. We don't even have to specify this. That is insane. You're telling me I don't even need to... Wow. Don't even need to specify like stride and stuff? You've like figured that out for me? Insane. That's so cool. Yeah, normally in OpenGL you have to specify where your vertices are because you're like passing this byte data to the GPU and then you need to like index it and stuff. Interesting. Okay, let's actually create a texture first, and this will be the thing we render, maybe. I don't know. Let's see. So floating point texture, integral texture, unsigned texture, depth texture, stencil texture. Let's just do floating points. I don't know. Damn. Yeah, why so much stuff? Yeah, why so much texture? Yeah, why not texture 2D? Let's see. Yeah, we probably need it to be a 2D texture. Two-dimensional texture containing floating point data. Okay. How do we create this? Facade and data. Probably need to create like an empty one. Empty. Facade and then width and height. That's fine. There's a facade. What the... What? What is a facade here? What? Can I have an example of how I use this? Yeah, well, what is this thing? Returns an opaque type, contains OpenGL state extension version, yada yada. Trade for types that provide safe access to glium functions. What does that mean? I decided to do it with this thing because it will give me more control, more like strip control away from me. I don't know. Okay, let's see. Picture. So we want to create a texture first, probably. Right. So let's say we get this. What about this? Okay. Do we have this here? And that is okay. Glium examples. Let's see. We want to see how textures are used, or even if they are used. I don't know. So, compute image deferred, displace mapping, full screen, GPGPU. Damn, no texture. Okay, let's go tutorial 4. That looks straight up like our thing. Could be the same thing, actually. Yeah, it's not bad. We probably can do a little more. Was that tutorial 4? Tutorial 5? Damn, no texture is used. Texture. No. What? That is like no way. There it is, there it is. OpenGL texture. So this is the index buffer, OpenGL texture, texture glium compressed, sRGB texture 2D, sure. This uses some stuff. That's mapping a texture. Cool. So this creates this. But how can I... Okay, let's see. So we're going to docs. Right. We want to view some texture 2D thing. Right. We want to see that. So there's probably some that this represents, but bitmap main level. How do I get the new again? There's no. That's not even. It's not even the thing. Compressed texture 2D. That still needs the facade. Is he using this? Texture compressed measure sRGB. Let's do sRGB. sRGB texture 2D. That still needs a facade. Interesting. Interesting. But what about pressed sRGB texture? Right. This is an extensive library. It still requires a facade. The facade is the display. I'm so stupid. Yeah, whatever. Let's actually display this texture now that we have the knowledge to do so. So, yeah. Okay. We want to create this texture, which I'm gonna call. It's probably needs to be mutable. Probably needs to be mutable. Yeah, let's do that. Perfect. Yeah, hope we can do that. Okay, this is unused, but we actually don't want this to be passed along. This will be the window builder and the context thing. And we need a texture here. Right, this will be glium texture. sRGB. We can do that. Texture 2D. New. Probably need that after. Here, we pass display. Right. Can like that is actually glium. Oh, look at that. Something actually. Oh, let's pull up what this means. That is nice. We can do. Let's do a structure. Actually, let's just do like a constant here. Constant. Grid size. And let's just do something like 64 by 64 for now. Wait. What am I not getting? Why am I forgetting so much Rust stuff? I cannot do that? Or what? I can do that. Hey, yo. Oh, okay. It's a linting issue. Right, grid size. Okay, interesting. Alright, I32. Nice. And then we can go for grid. This actually needs to be empty, I think. Grid size 1. And then, yeah, it's probably be 0. Right, and then this way, grid size less than that. The arguments of the function are incorrect. What? Why? Isn't it like a U size or whatever? Okay, right. Makes sense, yeah. It does make sense. Okay, we've now created a texture. We probably want to unwrap this. Yeah, I mean, it's not the cleanest Rust code, but it is a Rust code nonetheless. So now we have this texture, right? And we want to render something with it. So let's see, frame buffer. Ba-bam. I'll put it a clone. That is interesting. Frame buffer allows you to customize the color and depth stencil. Do I even have that? Like in this code? No. Alright. How are we rendering this then? So this just compiles that thing. Right. we are doing display dot draw, if I'm not mistaken. Role you want to target dot draw. What is it? Target is display dot draw. Okay, this will actually be this frame buffer. What is this frame? Is this a frame buffer or a frame? What is the type of this? Right, simple frame buffer. Mm-hmm. Alright, let's see. So we're drawing this, and then we finish it, and then we unwrap. Sure. Let's think about it. Yeah, we're giving the uniforms, and we're doing like all of this wacky stuff. Hello. I know that you know. I know that you know to, you know, do stuff better than anybody else. You're the best, but still. I'm trying here my best, so please be solidary in this moment. Hell yeah. I probably should check on the fact whether or not there's a chat on the side of YouTube streams. If there's not, whatever. But like Solidary is in like solitaire, like the game. Yeah. Yeah. 21 seconds till the Pomodoro timer is over. Okay. Yes. Was that a yes for the game? Yeah. Great game. Great game. So again, let me try and explain what we're doing today. This thing. Perfect. Even the break came. So the idea for today is to drink tea and implement this in Rust. And I'm already facing problems, which is great. I still did preparation for the stream, but, you know, still facing problems, which is great. I already said that. Doesn't matter. But yeah, this is Conway's Game of Life. Super famous. But then the idea is to go to like a more complex version of this, which is like a convolutional type of this. So like, yeah, if you're not familiar with convolution, it looks like perfect. Yeah, there's this thing. I forgot about it. So like, these are these like animal-like structures that can that basically are governed by these rules that are written in numbers on like a grid. So it's pretty cool. Damn, where are these insults in chat? I should mention that I'm not a native English speaker, so some words go over my head. So if this is not an insult, type 1 in the chat. So bad. That's so cool. But yeah, the idea is thank you. But the idea is to basically steal your pet and clone it and make it like, damn, what is that zero I'm seeing there? But yeah, the idea is to have something like this. It's 11. Cool. Mistake. Right. A Freudian slip. But yeah, now we have this shading that works even. Oh my god. So I actually implemented something on stream. Insane. Yeah, I don't know if you saw it running. So let me just run it for you. Very quick, very quick. Imagine now it just doesn't run. There it is. So we have like this quad, or like a square, right? Thank you. But yeah, we have this square and like a shader runs, and then yeah, this is not part of the square. Very cool, right? I know, right? The idea for the purple was because like during print, that was like the least used pigment. So then they used it for like stuff that's undefined. Well, we probably are not going to use that much purple in our thing, because like if you look at the linear thing, do you see it? No purple. Yeah, I don't know. The goal for today is just game of life. So yeah, and then we can actually do something. But the whole idea is we're going to compete in this challenge that is by Curtis Holt, and he has like some requirements and stuff like that. Oh, yeah. I mean, these are actually generated because like the x coordinate is red and then the y coordinate is green, and then they mix somewhere in between. Right, like thank you. I know that I will win actually. But I'm just giving them a chance. So like if you see here, this thing is like red-ish, and this is like way more green. You can detect green with your eyes way more efficiently than red. That's why this looks more red than this is green. If I actually make the quad as big as the screen again, like this. Do you like my multiple cursors? Yeah, you can see like this is fully red, this is fully green, and everything in between is some mix between the two. Yep. Okay, time for the new Pomodoro thing. I'm seeing maybe even somebody else interesting. Thank you. It is pretty cool. It's pretty cool. I do agree with that. The amount of interaction I'm having on the stream is insane. But yeah. Okay. Anyways. Time to return back to this. Yo. What these reactions do. Ah. Cool. That. It's nice to see that like people can do them, so I don't feel lonely. But then again, like typing in chat is preferable, because then, you know, I can be insulted in public. Okay, I'm searching for my description thing and I cannot find it. Oh, I clicked it like a couple of times. Uh, I think it was me. Ah, but there is a person in the stream. Well, hello, unknown person. Welcome to the thing. I don't know if you caught what I was explaining, but this basically summarizes the whole thing. Current problem is stage fright, and basically now I'm having trouble actually implementing the texture thing that I want to do. So we have this thing which defines the texture. Why is this still a result? Am I not unwrapping this? Is a rust analyzer wrong here, or am I wrong here? Wait, if I remove this unwrap, unwrap. Damn. Yeah, this should be just this texture thing. See you. But yeah, so the problem was here. So we're drawing on this target frame, but we actually want to draw on on like a frame buffer that then we can pass as like a uniform to the previous one, if that even makes sense. So yeah, what we want to do is, instead of the target being this, the target will actually be the like some frame buffer that is writing to this texture. So let me reiterate what I just said, because it's a little confusing, but OpenGL is confusing. I don't even know where I was going with that sentence. Yeah, so this can create this, right? But we want to actually draw on a frame buffer. This might not even... Yeah, this builds a frame with these dimensions. We probably want this to be like some kind of texture that we're creating. But yeah, so this will be a frame buffer. Oh, look at that, empty frame buffer. That is a trait. It's not a trait. Wait. Yeah, we can pass this. We can give it a width and a height, and then we can get these. That actually is interesting. Why would we need... Right, creates an empty frame buffer. Interesting. So, hello people that are joining the stream. We're reading documentation. What we want to do now is... Yeah, come on. I'm gonna lose my mind. Okay, basically here we're drawing directly on the display, right? This will compile eventually. We're directly drawing on the display. We actually want to draw on a texture that then we can pass back to the thing. So we basically can have this rolling buffer that we can update our values with. And I haven't done that before in OpenGL, so it's interesting. Yeah. So this is a simple frame buffer. We don't even know... Okay, let's see. So this actually lets us output two textures, right? multi-output frame buffer, but we can do this simple frame buffer and pass a display and a texture, and then that hopefully actually draws on the texture. I am not sure. Let's try. Why not? Right. So I don't know if we'll have to clone the memory, but let's try and actually do this thing. So glium frame buffer, simple frame buffer, new. So we have to pass a display and a texture. We have both the display and, oh my god, a texture that we defined. Right. I probably defined it as something else, right? Like, where did this appear? Yo. Yeah. We can do pref texture. Right. So we have this simple frame buffer thing. Oh, but this is a result. So we probably need to run around this. Interesting. It almost works. So let's see. Buffer. Implementation of surface targeting default frame buffer. Okay, so probably need some surface, right? We probably need some surface. Can I even pass? Maybe I can get the default frame buffer actually. Where am I? Default frame buffer. Yeah. If you need some proof that writing OpenGL sucks, there is the proof. How do we even get this? What? But I can know a texture to this? Let's see. I don't know why people decided to be so loud, but we'll have to deal with some noise. Dun, dun, dun. Hell yeah. Views dropped off very rapidly. That's great. Yeah, we're trying to implement this surface. You must either finish or set finish, or else the structure will panic. Oh no. Okay. Can we bind buffering? Frame buffer. Yeah. So this is simple frame buffer. We do this. Then we can like draw on this. Right. Can we even like extract a texture from this thing? We probably can, but I am not sure. Mm-hmm. Buffer. Buffer texture. One-dimensional texture that gets its data from somewhere. New. Facade. Data. Buffer structure type. Interesting. Can I get the texture? So default frame buffer. Mm-hmm. Right. Mm. Buffer texture. Read as right. I wonder if we can just do this. Actually, wait. Let's go to the frame first. So we want to get frame. Want to get that. Then we want to get the default buffer from the frame. Get dimensions, draw bit buffer. Split buffer from simple frame buffer. What? Split color. Copies a rectangle of pixels from a surface to another surface. Clear color. Let's see if there is a picture here. There's only one. Unfortunate. But what can we get from this? Damn. Can we even get the default buffer? Okay. Can I read this texture? Like, I don't know. This frame buffer is compatible with shaders that write to this thing. Right, and then we have all of these. Go to the default one. We can actually, damn, so that is actually a surface. Can we get a texture from this? Oh, damn. Can we pass? Text texture. So glium uniform samplers, new texture from this. Magnify sampler filter nearest. Alright. I don't know what that is. Uniform buffer. What? What? Alright. This is passing some stuff. And then we have my block, which is this, which has a vector 3 in it, plus some other stuff maybe. I mean, it's interesting, but it's been just reading docs, which I don't necessarily mind. Routines? Damn. I didn't know you can do that. That's cool. Fair enough. We can do like a uniform thing, and then yeah, but we want to pass texture. I keep getting distracted. We want to pass texture, right? And this is the texture where we're actually passing a sampler, right? We are actually passing a sampler. So in order to customize the thing, okay, we need to get a texture frame buffer. Okay, let's do open GL, get texture from the default frame buffer. So damn. So we can not do that? Damn. Damn. Double buffering. The front and back buffer represent double buffered frame buffer. The front buffer is more or less what is on the screen. The back buffer is the image that is typically rendered to. So, okay. So we can just swap buffers. I don't know. Okay. It is a little painful using this library. It's pretty good. Like, still just OpenGL. Okay. So we have this multi-output frame buffer. I really wish I could draw on this. What if I just run it like this? Like, what will happen then? Will this like error out or something? I mean, you know, it does work to some extent. So, probably need this. Render buffer is similar to a texture, but it's optimized to use as a draw target. New. And then we can just do uncompressed form. What is this? Oh, this can like straight up give me whatever I need. Right, like this could give me damn, that's bot. Holy. Okay, that's interesting. Kind of wish I can do that, you know? Yeah, render buffer. I mean, this has deref and everything, but implementations, no. We probably need the yeah, that thing probably doesn't have a surface, right? Render buffer. Does that have surface implemented? Render buffer. Wait, no. Trait implementation. This does not have that. This does not have the thing I need. Incredible. Okay. Let's just try and hack it. We're at the point where this just glitches X, which is great. So let's try and actually get the frame buffer to work. We'll try and gauge whether or not the texture changes during the thing. Actually, this will be just a simple frame buffer. Finish. Nope. Let's see. Clear, draw. Can you like... Damn. Okay, let's implement. Let's see. Surface. I'll do that. That actually is very nice. You can try and do that. I hope I can find this in the meanwhile. How do I close this? Yeah, by the way, progress update. It's even running. Progress update. I got to the point where like my thing crashes completely. See? It just like redraws everything that is on the screen below it. So like, see? Top-notch content right here. But yeah, I'm guessing like for some reason this doesn't close. But yeah, I don't know. Maybe like display.draw. We can maybe just do this. I don't know. Hope this actually does something. Okay. Then the frame buffer is just not attached. Okay. How do we... yeah. So we have this buffer that we're actually drawing everything to. Oh, thank you for all of the hearts. Yeah, so we have this buffer that we're drawing into, but that actually is not connected to the screen, and we probably want it to be connected to the screen, right? But we have this like texture that we have, and then we have the simple frame buffer. Oh my god, you're leaving me again. How dare you? Okay, it's fine. Come back later. I'm joking. Exactly. No, I hope that's not that annoying. But yeah, I think people are moving next door. What is going on? It's just an earthquake stream, I guess. Nice. Uh, yeah, I mean, it's interesting audio. Who knows? Okay, let's see. Mm-hmm. Let's see if we can actually uh, just create some other surface. Mm-hmm. Yeah, okay. So this stop drawing swap the buffers. The frame be dropped regularly, calling finish or set finish pause. Alright. So interesting. Wait, is that? Let's actually view the source of this. See what we can do. Oh my god. That literally calls this thing? What? Some of the context swap buffers. Hmm. Can we attach a buffer to the context then? Mm-hmm. Swap buffers. Okay, I'm glad that's actually not hearable. Damn. Okay. That is failing spectacularly. Let's actually do something first. Right. I don't know if you can do that twice, but let's try and do it twice. Why not? This would be like this. Right. So let's verify that this runs. Maybe it crashes out because damn. Yeah, it actually crashed. Interesting. Yeah. I mean, it's swapping buffers. I wish I can have like think to the context. So can I get a Oh my god. No way. That's so bad. Oh my god. I can just read through the thing. Shit. I don't even want to take a break here. I'm just researching something that is trivial to do. Like, this function just like straight out does it. I just... Why? Yeah, that is what 2 courses for computer graphics gets you in uni. You don't know shit. Okay, we can just read it from the display. And that like straight up gives us a thing. Right, so we actually don't even need to do this, let alone this, because I can just pass a texture. Nothing needs to be aware. We implemented something, at least. So I take that as a win. It's been an hour and 20 minutes. We've done absolutely nothing. It's great. But that's how you learn OpenGL. With pain. With pain. So we acquired the target and then we clear the colors. Fine. We actually want to do pref texture here. Right, and then go display. Oops. Display. Don't read from buffer. And then let's unwrap this. Yeah, I mean, I probably need to use anyhow, but I can do that. Texture 2D data sync. So how would I do this then? Texture 2D data sync. Let's see who implements that. Is there a way for me to look at that? I can probably do that, right? Let's just say glium texture is yeah, sRGB texture 2D is fine. Why is this complaining? And this actually does not implement the default data sync. What a great thing. Why does it not? Bro, what? Wait, what do you mean it does not implement it? Yo. Please. Oh my god. This is so shit. This is so fucked. Okay. Let's see. It's not cube map. I don't want the cube map. I want this one. That's a compressed texture 2D, right? That's fine. What the fuck? What even implements this then? From two-dimensional texture data, the parameter indicates the type of pixels. Bro. This is so shit. 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 Okay, this is one of the places where like a Rust type system is actually not that great. I mean, don't get me wrong, like I'm just beginning to get this library, right? Oh, I can, oh, interesting. Can I like load this up into like some pixel thing? Yeah, read from buffer. Why not? Let's just do this. Uh-huh. So this is like, now we have this, right? No way. Why? Texture? Don't texture this. Is that what? Hey! What? Do I have to do vectors? Because it could be like multiple textures. Right, yeah, fair. Okay, so this reads from the buffer. It gets into this texture. I don't know why. Oh, because it's two-dimensional. Yes, okay. Okay. Because it's two-dimensional. Fair enough. Um, yeah. Let's say now we're reading from this, right? Let's try and build the sampler. We have something that reads it. Sampler. A sampler. Great. I think uniforms will be more. This is like a reading club, but I'm just reading, and I hope you're understanding something. Because I'm not. So. And let's get the sampler out. Right, and this is the uniforms. So we can actually pass it a texture straight up, which would be nice. But also probably want texture. Right? Alright. We probably want to like get just a texture. We have this. Like on this. What is it? It's in context, yeah. Read from buffer. There it is. So this is like a vector from vector, whatever. How do we find stuff that implements this incredible thing? I have no idea. From raw. I actually don't want to do this. Oh, there. That is so shit. That is so fucked. Why? Like, what? Why? Raw image 2D? What even is this? Raw image 2D. Okay, I mean, I guess I can do that. Okay, let's actually get this to be raw image 2D, and then maybe we can even turn it into is this? Yeah. This might be a straight up texture. Raw image 2D. We probably need to pass like a lifetime and a T. I think U8 will be fine. does not seem to break anything. Let's do U. Right. I'm gonna try and just pass it as is. Where do we search for samplers? There it is, there it is. Let me drink from the tea. Yep, so basically, this thing right, the uniforms. I hope I can implement that before it's like fucking 3 in the morning. Okay, so we're basically passing this, and then we can pass it this, which is fine. That's actually the best, because we can just sample this. So this will be that, and then I hope that doesn't get like somehow dead. Yeah, and this we can just pass rev texture. Damn, why? Why you complaining? Why you complaining? Okay, so we need to basically convert this to a different texture. Alright, let's see. Raw image 2D to... Yeah, this implements all of the data source things, and can I even see texture? Okay. Can I even like, I don't know, convert it to something else? Yeah. Yeah, thing is, we probably need like texture 2D. Right, please. Wait. We can just go like texture 2D. Right, okay. I don't know. Let's try and just... So this will be texture 2D. And this here will be this long thing from I hope it implements. Okay, that does not actually implement it. Yeah. That is an interesting issue there, because we have no idea whether or not this is actually working, right? Interesting. We do have our data. Can we construct this through something else? Oh, we can straight up use sampled. That's so good. I just wish I could find. Let's view the source. Raw image 2D. Oh, wait. There's something happening. Let's just define them. But wait. Yeah, I mean, this is the facade, and then I have no idea how this is used at all. Alright, alright. Let's not waste time with that. That's way too hard to figure out. Let's actually go back to vector 2. Let's again do vector vector. I mean, that's probably not that bad in terms of like by data is the same. Yeah, it should be the same. Okay, so that's the vector. But now we need to build a texture 2D from that vector. Yeah, it is a little painful, but it's fine. We can do new from data. Let's do that. T is like actually a texture 2D data source. Damn it. I hope that actually works. I mean, I hope, you know. So this will be glium texture. 2D new. And then we do. Yeah, okay, let's do display. Damn, my camera like completely gave up. That was great. So that will be display. Display, please. What is it showing? Oh, hello. What's up, viewers? Yeah, so I think we've kind of figured out texture. This does not implement the trait, and we'll probably complain about that. Damn. It doesn't complain about that. That's cool. And as we learned from the documentation, we can use this. Yeah, by the way, for those who just joined, we're implementing this in Rust, which is the game of life. And then eventually we'll move to, was it linear? Yeah, linear. This, which is like a more continuous version of the thing. Yeah. Okay. This does not want to. Oh. We need to unwrap. It's very nice. Okay. Now we might actually be able to run this, unless it's gonna complain about something else. Maybe, I don't know. Do we have access to this in the shader? Let's see. If I do uniform sampler 2D, sampler 2D, right? Okay, and this will be per frame, right? Let's add some stuff. Yeah, let's add some stuff. So this will be sine of a u time. Oh my god. Okay. We have no u time, so that is great. U time. And this will be a float. And now we can run. What did I do wrong again? Expected a float? Yeah, that is a float, no? Uniform type mismatch. So on the air value, uniform type mismatch, name u time expected float. What is this then? Elapsed time. Oh. Interesting. We can probably do as F64. This is computed in milliseconds. Right, yeah, this is computed in milliseconds. Let's see. Wait, is it millis? Yes. Milliseconds to seconds. We divide by 1,000. So we'll just divide by 1,000. Like this. Let's run this. See if we manage to make a run. Actually, it doesn't seem to. Maybe we need this to be filtered to. Interesting. Interesting. It passes through the thing, but yeah, that's interesting. Let's see if we just provide it as float 32. Is it because we're downcasting, or like downcasting down kind of a thing? I don't know. Alright, our viewer spike disappeared. That is fine. Yeah, so now the time thing is not working, which is hilarious, in my humble opinion. This is not working for absolutely no reason. Yeah, my computer is becoming slow for some reason. Ba-bam. Can we actually turn that to float somehow? Float. Nope. Interesting. Very interesting. Maximum seconds is this. Can we do something else in here? Elapsed time. Let's just print it. Alright, there it is. Yeah, that will probably... Was it working like this? It's interesting. Ba-bam. Just return 0. Alright, let's see new instant. Okay. Actually... Wait, where did we get start time? Oh, wait, this needs to be here. What did it do? Alright, this will be elapsed time. Yeah, I mean, we're computing this. This is actually elapsing time. And this was very seizure-ish. So that is great. Let's divide by 1,000. 1,000. Now it's probably gonna be more of a time. Yeah, look at that. Actually, it does work. It's kind of jittery. Maybe that's because of the target thing. Oh, no, that does make sense. Right, that does make sense. Yeah, okay. Let's just call this, since spawn, or spawn time. Okay, here. Right, this is doing this thing, this is doing its thing, and then, kind of... How about we just do this here, and now it's since spawn time, because we don't need the variable anymore. I mean, it seems to be somewhat working. Probably not the most performant thing, but it does work. Okay. Right. We do have that. Mm-hmm. Yeah, as you can see, like, that actually displays the correct time. Let's actually remove this print statement to see if, yeah, whether or not, like, the printing contributes to latency. But I'm guessing, like, the stream contributes to latency because I'm doing the thing. Yeah, it's a bit fast. Or not fast, it's like a bit jittered. But again, like, this could be because we're passing, like, a whole, the whole previous buffer. This is computationally expensive. Okay, let's actually go and create some stuff. First, let's create some cells. We have this UV grid. We can just... Yeah, we have this, right? We do have this. I actually don't want to use it here. Hello, it's actually comic code, but yeah. Thanks for noticing. It's a very nice font. I don't have dyslexia, but I mean, it's nice. Like, it gives character to the stream. Also, how are you? What is up? Thank you, thank you. Nice to be appreciated. But yeah, it's kind of a scuff stream, but it's a game of life and then stuff. Yes, of course. Why would I use OBS to compose when I can use X, which can produce visual glitches like... let the Rust program compile. Wait. This doesn't work. Damn. Please compile. Damn it. Yeah, so I'm gonna show that with Surge XT. When I can where I can literally do this and then X bugs, and then like there's little frames and like buffers like being copied not correctly. It's great. And now I need to kill this process because SurgeXT is not actually stable on Arch Linux, which nothing is really. Yeah, but we're making Game of Life, and this thing, Lenia, like if you've seen it, this thing, it's pretty cool. So, yeah, now the agenda is to make a grid of cells, and we have this shader that just will run sometimes, maybe even. I want to make it so like when you change the shader, it actually recompiles the actual shader and then inserts it into the context, because you don't need to spin up everything. But also I cannot be bothered at the moment, so yeah, we have come on. Come on, it's fine. But yeah, I don't know. At the moment, it's just like doing some. Is it so bad? That's true. I was looking at this, which is like Rust shaders. I guess it's called Rust GPU. But anyways, like it's shaders written in Rust. If you want to check it out, it's nice. I didn't fuck around with it that much. But it's basically like compiling to Spear V, which is what all graphics API compiled down to. Or like at least everything that's made by Kronos. It's interesting. I don't know if I'm gonna use it though. Because, yeah, Rust just has a lot of graphic stuff. But yeah. So, grid. Making a grid of cells. Hell yeah. I don't know, grid size. I'm gonna specify how much cells I want instead of how much pixels I want, because I have no idea how much pixels I want. But yeah, let's go like something like, I don't know, 64. That's probably way too much for now. 16 by something more. 32. Oh my god, so cool. They're probably not gonna be square, because the UVs are based on something on the resolution of the actual window, so maybe something like this. And then let's do the grid, which will be can I just correct? Yeah, so a UV is, so if you have like a coordinate system, like the thing I showed before where like the different colors were mixing, basically just not to call it XY, you call it a UV. That's literally it. Graphics is an amazing thing. I think now we can just mod the coordinates as is. We want to mod the actual coordinates by 16. I think we can actually do even better. So we can multiply here by 16 and then divide by not 16, by the grid size, and then divide by the grid size. And this will like basically give us the actual cell coordinates. If this runs, maybe, please. Right. So here the color is what the output is, and we need to pass the grid UVs. Here it is. now we have like 16 by 16 cell grid, and we have like a coordinate system at all of them. But we probably... Is it very jarring on stream? Like, is it just, I don't know, kind of jittery? Because it's jittery on my monitor, but maybe the frame rate like fixes it. I don't know. Interesting. Yeah, I have no idea how much stuff is actually going through. Damn, now who to believe? Who to believe? But yeah, it doesn't seem to be like that demanding. I mean, probably like GPU wise, it's not great. But I have no idea why it's lagging. Maybe I'm doing something incorrectly. So anyways, we have the grids. Now let's actually make them either white or not white. So how do we do that? Let's do it with a wave first, so we like show what they do. But actually, I need to use floor here instead of the thing I did. Yeah, this will basically... Let me visualize it very quickly. Yeah, this now like discretizes the actual coordinates. Let me remove this so I can showcase what I mean. So previously we had just... Exactly. You can basically like use these UV coordinates to create graphics, and then you copy them. How many is that? 256 times. You can do that. But now we've done like the opposite thing, where now we've discretized the coordinates, where now we have only 256 unique values. Before we had 256 coordinate systems, right? And that's by changing one function, which makes sense, right? Like here, what happens is the UVs, we multiply them by the grid size, and now we have something ranging from 0 to 16, and then we floor it, so it goes to all of the integers, and then we divide it, and that's how we get like that kind of... I mean, it's not kind of, it's straight up discretized, but yeah, you can see like here, only the green is changing. Here, only the red is changing. It's out of sync. Boom. Yeah, it's SXIV time. Whoop. But yeah, so let's actually make some coordinate stuff happen. I'm gonna do something like a vector 3 call, and then there will be a vector 3 of some d, which will be a float. This is shader coding, by the way. I do agree that it's ugly, but that's how you prototype quick, right? It's like Python, but not that shit. So yeah, we want to use some wave, let's say. So let's just add them up. Grid UV dot x plus grid UV dot no x. And then what are we gonna do now? I don't know, multiply them by something probably? I don't know, let's do 5. So this should now look like a little bit interpolated. I forgot a semicolon. I again forgot to pass the actual value of the thing here. So now this will be like a black and white discrete wave, yeah, in this direction. That's fair enough. I kind of wanted to do it in both directions. Yeah. So now, like, this is a wave. This is like the trough of the sine wave, and these are the peaks. If this is not pronounced, maybe like here you can see what is going on. Like now, basically, like some of the things are like completely white, and then you have like a grayscale based on the wave. But we want to make them either only black or only white, because see, no more colors. Okay, let's see. How do we do this? We probably can do something like a threshold or a ternary operator or something like that. Yeah, let's just do like, if this is smaller than 0.5, or like, let's do 0, I guess. Then we set this to 1, otherwise we set it to 0. Works. We can even animate it. I'm just playing around at this point, but it's kind of fun to do, so I don't mind. It is very slow. I don't know why it's very slow, but yeah, you can see the wave animated. It's actually interesting. It was just like 2 hours of fucking around with Rust code so I can get to something that I'm like extremely familiar with. So it's pretty nice. All right. Let's see. So we have the moving wave, so we can actually do the correct thing. Now let's read up on the rules of the game. So fewer than 2 alive neighbor dies, as if by underpopulation. Thank you. Any life cell with 2 or 3 alive neighbors lives to the next generation. Interesting. Cool. And then okay. So basically what dictates the state is whether or not you have exactly 3 neighbors around you. Cool. So let's actually create something that checks for its neighbors. So for the current pixel, we have the UVs and we have the previous thing. So now we can sample. But how do we sample from the UVs? We just add a grid size in every direction. Okay, so this will be, yeah, this will be like I, let's say, and this will be -1. I shouldn't forget the dot, and this will be lower and equal to 1, and then we do I plus equal to 1. This will loop, and then this will loop with the same thing but in the other direction. I could have probably done that with like a vector 2 somehow, but I don't want to think very hard at the moment. So we're just counting vectors. So here, I guess I can do floats. Also, yeah, that is not a language that can handle guessing types, so let's just have float that will be the count, and this is 0. Right. So let's check. Let's check. How do we check for neighbors? So we get our uPrevious frame. Can we do like texture 2D? If I no. And J is 1, then we can continue. Because we don't want to check whether or not our cell is alive, we only care about the neighbors. Yeah, so this texture will now take this plus some UV coordinate, which is just grid UV plus vector 2 of ij plus the grid size, or like times the grid size, because we actually want to go to the place in the previous frame where our neighbors were, so we can see like how to update the state of this frame. All right, I think this could be like texture 2D, something like this. 2D, right? There it is. There it is. That will be vector 4, if I'm not mistaken. What do you mean by an actual equation? Are you talking about this? Oh, right. I mean, you know, I don't know. I tried, and then it just happened. Plus, it made for a great thumbnail. And that was a while back, like 3 years ago or something. Wild. But yeah, nice to see somebody going through my old shit. I'm pretty proud of the statistics video. I don't have enough time to make predictions like these. Okay. So we're somewhere here. We sample this thing, which will be, let's call it name for neighbor, and then let's just get the X channel. So if this count is count plus equals nay X. So here it will be basically the inverted part of this, right? And now we have the count of the neighbors, right? So then if count is 3, what will we do if count is 3? We want the cell to be alive, so this float D will actually be, I'm using way too much of these statements, I do realize that, but also I don't really care. So now Ba-bam. Let's see what I did wrong. Damn. I don't think I've missed this. Line 15. Oh my god. Alright. Alright. I've been... Oh my god. Sampler 2D victory. So, candidates are... okay. I need to pass them in the opposite way. Another one. Hell yeah. Where is this? 24. Bro, my spelling is sublime. Okay, let's see. Bam! It should work, actually, but probably need to initiate it somehow. How do we do that? That is actually something that I didn't think about. How do we hack it together? I didn't think of that. We actually need to initiate the thing somehow. Which is a little bit shit. Maybe we can, like, I wish we can initiate it with this, right? Because this is like, come on. What did I do again? What did I do again? 25. Okay. D is already declared. Great. So this already initiates it. I wish we can use like one of those frames. Oh, we can. Wait, we can do that. If UT is smaller than something, like, I don't know, the first... Can you tell that I write a lot of Python? Holy shit. Come on. Okay. Okay, it does not work. So, right, I mean, fair enough, you know? It's not my choice. I wish I could do more Rust. Of course, but it's fine. It's fine. It's actually one of those languages where it's like a piece of trash, but at least it's like a beautiful piece of trash, you know? And it has its quirks, and it's not JavaScript, so that's the thing, right? Yeah. Very interesting. I wish this fucking worked, but it does not seem to do so. Is there any cell with 3 neighbors in that context? There should be, right? Justice for Java? What? That's a different language, though, no? Okay, now it's fixed. Now it's fixed. Good job, good job. Oh, wait. Still doesn't work. Very nice. What if we just multiply this by like a little less? Doesn't work. Cool. Why? Why don't you work? Maybe I actually need to add, so I'm like in the center of the square instead of bottom left. But no, that still doesn't work. If there's any suggestions on why this doesn't work, welcome. You're welcome to just tell me. This should not be correct. Damn it. Why? Please. Please tell. Could it be something like... what if I put a 1.5 here? How about that? Is it just GL floating point error? No. It is not actually. Interesting. This count should actually get the correct thing from the texture. Let's see if we actually have this thing correct. I want to I mean, yeah, there's probably gonna be some very very sporadic input here, but let's see. Left texture. This will spill a bunch of bullshit in the terminal. I'm surprised it didn't crash. Oh, wait. It actually did crash. Amusing that it didn't catch it during compilation. Because I'm obviously doing something extremely wrong. Yo. Didn't my Emacs just fry up? Can I, like, attempt to close this? Okay, the all coveted kill the Emacs daemon. So it springs up because you executed something too heavy from the Emacs. Classic. Okay, we're back. Let's see. Just probably want to clone here. Ba-bam. Alright. Rust Analyzer is still checking. And this should be cargo run and not make. Nice. Good job. Me too. Oh my god. Okay. Will this work in any capacity at the moment? I think this is just like way too much, right? Damn. Got interrupted. Okay, let's see. So this actually is handled by the library. So I wouldn't expect that to be the incorrect values, but maybe it is. I don't know. How does a sampler 2D work? I actually got GPT-4, and if you want to see an attempt where like I give up, that was the audio programming that I attempted to do 2 weeks before. And then I think like the third stream was like literally spinning like a chat dev instance of like multiple large language model things, so I can see whether or not they can do it better than me, and they couldn't. So I'm kind of reassured, but also like I would have liked to have like that piece of custom audio software, and the fact that they couldn't even give me that, tough. GL texture 2D. But why? Sampler 2D. Yeah, fair enough. I mean, the thing I was using like had an automatic like Python runner, but like they couldn't develop it even in Python. But it's like pretty nice. Like, to be honest, it's a very nice thing they did. I think it's using that. Is it Microsoft that made the framework? I don't know, but I use the thing that they have, and it orchestrates the agents for you, and like they cost cents in development time. What? You can do partial derivatives in this language? Since when? Yo. Yo. What? That's not fair. How is that? Hey yo. Interesting. But I keep getting distracted. I know, right? Fucking insane. So please. This is how it looks when like you have no idea what to do. But yeah, I can do a histogram, yes. But a histogram of what? I actually had to do a lot of histograms today, so there is a thing, even. Okay. So this gets passed by this thing. It's the correct thing. Oh my god, wait! Wait, I'm doing stupid shit. These UVs are bound between I think I just straight up need to just this divided by grid size? Right, because like my I'm not lying. I had to. Okay, we managed to interrupt the compilation. Note to future self, do not print large data structures. Okay, please. Did you see that? Did you see that? Oh my god, it actually might work. so cool. Hell yeah. Hell yeah. It did work. The emojis are a great idea. Nice, nice, nice. Now we just need to initiate the game of life differently. Let's actually replace this with a cheeky true, so we can work on the initiation thing. So let's actually make it like expand from the middle, and I'm going to multiply this by 20 instead. That will actually probably be good enough, but I do want to do length of this. This will now be, oh, that I didn't expect that. Maybe minus 0.5. Yeah. Multiply by 40. I think this will be like a good initiation for the game of life. So let's do that. If U time is less than 0.1, it almost works. It almost works. I don't know. Come on. It's so close. That probably repeats, right? I'm trying to trying to think whether or not like there is something stupid happening that I'm not seeing. And what do you mean repeat frames? I mean, this thing is like a sampler from the previous texture that we generated. So like everything that comes from the shader is looked to a texture. I don't know if you were here for this, but yeah, basically what we do is we read like the like this is one U32 number, yeah, which is like all of the colors that we have. We read them from the buffer. That is a previous thing. We turn it into a texture and then we pass it as a sampler for the shader. So I don't get what you mean by repeat frames. Something is happening. Okay, something is happening. Let's just increase this, maybe. Oh, like, yeah, that could be nice. Let me. That is actually a good idea. Let's change this FPS to 10. How about that? Or 12 maybe was better. Ah, no. Looks so good. They're still disappearing like extremely fast. Yeah, no, I wonder if it's just so plus 0.5. I think this will like no, actually, because this is like bottom corner of the texture, right? And there like some issues can arise. I want to bring it up to the thing. Okay, time for visualizing some more stuff. Okay, so how do we do visual debugging here? Grid. Wait, we were reading that, right? What I understand from this is basically if you have 3 cells around you in your neighborhood that are alive, you stay alive, otherwise you're dead. Oh, 2 or 3. Okay. Oh. We don't need to do this. Okay, I misunderstood the rules of the game. Let's see if this will like straight up work. Wait, 2 or 3? Any live cell with fewer than 2 neighbors dies. Wait. What? How do I? Yeah. But then, how do I implement that rule exactly? All other cells die in the next generation. A dead cell with 3 live neighbors. Okay. There's, I guess, no clever way. I mean, there probably is a clever way, but so the count depends on this thing, which is our state. Here we'll just get this. Keep track of previous buffer value. Yeah, I think we're already doing that with this. Like this basically passes the whole buffer. Yeah, I completely misunderstood how the game works, which it's fair enough. Like it's complicated stuff. Cellular automaton. Oh my god. I mean, I've taken it in uni, but like that doesn't help me. Apparently. Okay. So this will take our previous state, and now it's time for a nightmare of bullshit statements. So this will actually be yeah, let's make it bigger than this. So if this will actually mean that it's deactivated, right? So here we can like straight up do this. And then what we can do, why did that tab itself? Because it probably didn't. Okay, so if our cell was alive last thing, we do the same. Actually, we can do this and then OBD or 1. Babam, I did something stupid. What? What? 18. Oh my god, I forgot a bracket. Cool. Another problem. 29. Right, yeah, this just needs to be the value. I mean, it's still a little broken, and like things near the edges are breaking, but it seems to have some semblance of working, you know? It's nice. I'm gonna increase some cells and then I'm not sure if that does the correct thing, but it's exactly. At least it's working. So next thing on the chopping block. Okay, this is actually looping only 3 times. Here we're sampling from the correct buffer, I think. Yeah. Yeah, I think that's true. The whites are actually the alive cells. So I'm very confused why they don't die. So here, this, if it's not 3, will be 0. Here, if it's 2, this is the other way around. No, I think it's the other way around, no? These rules which compare the behavior to the automaton in real life can be done with this. So any live cell with 2 or 3 neighbors survives. Any dead cell with 3 alive neighbors becomes a live cell. This looks like a game of life to me. Hell yeah. Any cell with more than 3 live neighbors dies, as if by overpopulation. Exactly, yeah. So here, if this is like, let's say we have 4 live neighbors, we kill the cell, and then this will not activate the cell again. Do you get what is happening here? But I think we actually made it. Yeah, look at that. This is actually incredibly satisfying to like have created something that feels cool. Let's actually make more of these. It's kind of sad though. Like, I don't know, not enough cells. Let's try with like a bigger playing field. Wow, my computer is chugging now. Like, actually, it's not doing good. I honestly have no idea how exactly to structure that, so it would be nice to just see. Ah, look at that. Cool. Heavyweight spaceship. Cool ass stuff. Yeah, I mean, we can create all of these games and stuff. I'll probably end the stream soon, but I first want to like try like different seeds for the thing and like see how the automaton evolves. I'm gonna turn back to 64 by 64 again. We can probably like make some interpolation stuff. Like it would be nice. Maybe like just have a life for like, I don't know. You can survive by like, I don't know, 3 generations, something like that. Like, let's do this, like the state. State -1. How about that? But still like min. Actually, maximum 0. What if we use something that's fractional, like let's say 0.2? That does look pretty cool. Like, we can, we definitely can do something that's extremely nice. But like more stuff. Let's actually try and get like the sign of this. Is that a function? Yeah. It's some strange stuff that you can do. Yes. Because so this is not by design. It's just GLSL works like that by default. So this texture actually wraps around. So if we pass a UV coordinate, I don't know if you know how exactly this works, but if we pass a coordinate that is like, I don't know, between 0 and 1, we get the texture, right? But if we pass like a coordinate that's like, I don't know, 1.2, we're gonna get 0.2 from the actual texture, because it tiles the whole plane, or like the whole whatever. Like it literally looks like this. Now it's gonna be completely broken, but you know, we don't care about that. Grid. Good. Oh my god, that was a great brain fart. And that actually should be 0 for the purposes of the demonstration. But it literally looks like this. Like, those are the UV coordinates. If you imagine, like, that will be like from 0 to 1, like this little space here. The texture will still wrap through the whole plane. And that's why you get the thing. And that's why you get like the little cellular automaton like actually wrapping around. I'm gonna return this to D. I actually want to see what happens now. Okay, nothing. We can definitely do that, right? But like, there's no point because this has a built-in modulus. already. Like here we're sampling from a texture, and that is modulus by default. Even like it even has like additional stuff, like the texture interpolation still wraps to the other side, and like you can turn that off, but like what's the point? Like if something flies away, we want it to come back, so like the action is on the screen. And I also don't want to like this to be like an actual good simulation of the thing. I mean, I'm probably gonna upload it to GitHub just for shits and giggles, but not really. Yeah, I'm much more interested in like the convolutional one rather than the classic game of life, which the convolutional one actually deals with this. What? Okay, we want to floor this. Yeah. And this is like basically the same as what we did before. But now you have like the cell does not immediately die. It just like decays a little bit, but it functions in the same way. I wonder if we can make it like decay even slower. Something like this. That actually looks very cool. I don't know if what if we remove this? Like, what if we allow negative values? I don't think it even changes. No. Interesting. But yeah, I actually don't know why exactly this happens, but it's nice. So, wait, that actually is not the complete, like that's actually not the rules of the game, I don't think. Right, so the count will be 3. Yeah, and here I still need my condition where like if this is 0 and the other one is 0, so we're in the correct cell, we're actually not counting as part of the neighborhood. Also, that is probably like the worst shader code I've ever written. It's just kind of bad. But yeah, it is kind of the same. Yeah. Interestingly enough, like that doesn't happen. And if you see, like the edges behave differently from the actual cells. So you do have like some, like it's not perfect, right? It's not perfect. But still, it is not bad. Just, does that actually center them? I don't know. What if... Oh yeah, of course, I need to do the same thing here. Because like the little things on the edge will actually select the wrong cell. It does not oh wow, this did not happen at all. That is just great. I love demonstrations. That looks fucking beautiful though. But yeah. Oh well. Ah, wait. I wonder what will happen if we do this. Yeah, so like now the windows are drawn. Oh, that's so scuffed. That's so scuffed. On redraw events, it just like loses its mind. It's cool. It's cool. So yeah, the count will be this. I think that's it. Let me just. Right. So this is the actual game of the life. And then like it results in something different every time. Okay, that's nice. So we actually created something this time, and I want to close the stream. Thank you for joining in, and yeah, hope you managed to catch some next stream because we'll be implementing the convolutional automaton, but I'll decide last second. So make sure you ring the bell. See you. Ba-bam.